In this video, we're going to be solving for x, where x is part of the exponent. It should be suitable for grade 11 and 12 students. So let's start with the first question. Here we have 2 to the power x is equal to 8. What you need to do here is to make sure that the bases are the same, right? So 2 to the power x is equal to 2 to the power 3. 8 is 2 to the power 3. So that's why we chose 2. It's because we wanted the bases to be the same. So when bases are the same, the exponents are equal. So you're going to say, therefore, x is going to be equal to 3. So again, when bases are the same, the exponents are equal. Okay, let's go to the next one. On this one, let's first write it out again. You need to find an expression for 125, preferably a prime number base. 125 is made by 5 to the power of 3, right? And we know that there was already an exponent, 2x minus 3 there. It's going to be equal to 0. And we chose 5 because we want to have common bases as usual. So here we're going to have 5 to the power of 2x plus 1 minus 5 to the power of 6x minus 9. I got this by multiplying here and also multiplying there. So 3 times 2x is going to be 6x, 3 times 3 is going to be negative 9. That's going to be equal to 0. And now, because we want to solve this equation, we will want to have 5 to the power of 2x on the left and 5 to the power of cx minus 9 on the right, so that we can then say bases are the same. And because bases are the same, we can therefore say 2x plus 1 is equal to x minus 9. So if we take 6 to this side, it becomes negative 6x. We drop negative 9 as it is. Positive 1 comes to the side and becomes negative. 2x minus 6x is negative 4x. Negative 9 minus 1 is negative 10. So what we end up with is, let me first divide by negative 4x on both sides so that I'm only left with x. So x ends up becoming negative 10 over negative 4, which is equivalent to 10 over 4 because the negative signs cancel each other out. Now 2 goes into 4 twice and 2 goes into 10 5 times. Therefore x is going to be equal to 5 over 2. That's how you do that question. Now let's go to the next example. Now suppose you're given this and you are used to reducing bases such that they are the same and solving for x. How would you do this question? Okay, so in this question you have to use a lot of tricks that I'm going to show you. So you could choose to say, for example, let me write it here, 2x is equal to 5x. You can just divide on both sides by 5 to the power x, 5 to the power x. You're doing this because you want to have 1 is equal to something, because it's easy to work with 1. I'm going to show you why. These two numbers will cancel each other out, these exponents, and then you will get 1. 2 to the power x over 5 to the power x is the same as 2 over 5 to the power of x. That's one of the laws of exponents. You need to know that by, I assume you know that by now. Okay, so we know that 2 over 5 is to the power x is equal to 1. What can we do on this 1 to make it the same as 2 over 5? It's simple. 1 can be turned into 2 over 5 by raising 2 over 5 to the power of 0. As a result, we're going to have 2 over 5 to the power x is equal to 2 over 5 to the power of 0. Now we have found our solution. We have been able to make the bases the same. Therefore, we can then say the exponents are equal. X is equal to 0. In almost any question similar to this one, you're going to use the same method. Even if you wanted to divide by 2 on both sides, you would still get the same answer. Let's try it when in a case where we would have divided by 2 to the power x. So we have 2x is equal to 5x. So let's divide by 2x to the power x on both sides. We would still get 1 here. And then this would be 5 over 2 to the power x. We would then need to change 1 into 5 over 2 and raise it to the power of 0 so that it's equivalent to 1. And therefore x would be equal to 0 because the bases would be the same. So yeah, that's how you do this question. Let's go to the next one. A question like this one often resembles a quadratic function of the form ax squared plus bx plus c. And therefore this suggests that we should also be solving it by taking out common factors in the conventional way, right? So you can see that this would be c, this would be c, and this would look something like bx, and this would look something like ax squared. Okay, so let's try to rewrite the whole thingy so that these all these exponents have the same base. 16 is the same as 2 to the power of 4, right? But then there's also x there, so that's going to be 2 to the power of 4x. And then this is going to be 2 to the power of 2x multiplied by 2 to the power of 1. We're just distributing the base amongst the exponents there. Then minus 2 to the power of 3 is equal to 0. Now you can already see that we can actually just say, to make things easy for us, that we can just say let k be equal to 2 to the power of 2x. The reason we're letting k equal to 2 to the power of 2x is because we can see that 2 to the power of 4x is going to be k squared, and that's going to be easier to work with. So we know that 2 to the power of x is k, right? But if we square it, 2 to the power of 2x is k, but if we square it, it becomes, the inside part is still k, right? But because we square it, we're gonna get k squared. So in the place of 2 to the power of 2x multiplied by 2, we're gonna have k to the power of 2. And by the way, this is equivalent to 4x, but I was just showing you the reasoning behind it. So now let's substitute in the place of 2 to the power of 4x with k squared plus, so we are basically doing this here. 2 to the power of 2x is k multiplied by 2 to the power of 1 minus 2 to the power of 3 is equal to 0. And then here we can further write this in a way that we are familiar with. 2 to the power of 3 is equal to 8, right? So we can just work with this the conventional way. We know that this is going to be k, this is going to be k. 8 is made by 4 times 2. 4 multiplied by 2 gives us 8, but then what can we do to get a positive 2? We need to have 4 positive and 8 and then negative 2 here. Okay. By the way, the rooster is making things in the background, but we move as collab. So here we're gonna have k is equal to negative 4 or k is equal to 2. So basically I'm taking these and I'm writing them here. And now we know that k is 2 to the power 2x, right? 2 to the power 2x is going to be negative 4. No solution for this one. You can't raise 2. You can't substitute a value in the exponent such a way that you get a value that's negative. That doesn't make sense. Like for example, let's say you have a positive, let's say positive 3, and then you raise it to 1. That would give you a positive number 3. You raise it to a negative, it would give you 1 over 3, which is still positive. You see, so there's just no way you would raise. There's no value for x such that when 2 is raised to it gives you a negative number. So there's definitely no solution for this one, so we don't consider it. Oh, I'm a roast. Okay, now let's look at 2 to the power 2x is equal to 2. This one is simple. The bases are already the same, so 2x is equal to 1. This means that if we divide on both sides by 2, we're going to have x is equal to 1 over 2. That's how you do this one. If you like this video, please leave a comment, a like, and make sure that you share it with friends. And don't forget to subscribe. Thank you.